Hi, welcome back to Moose and Chemistry. This is the combined gas law, lesson A. Now, unlike Boyle's law or Charles' law or even Gay-Lussac's law, the combined gas law doesn't have any constants. So in essence, what the combined gas law is going to be the following equation. P1 V1 over T1 equals P2 V2 over T2. But it's best written as P1 V1 T2 equals P2 V2 T1. Since we read linearly anyway, this is the best way to do it. Okay, so what we're going to do is we're going to write a problem down and we're going to solve for the combined gas law. Now remember, in the combined gas law, again, there are no constants. Every variable is being used. Okay, if a gas is at 12 atmospheres and has a volume of 23 liters and a temperature of 200 Kelvin, and then the pressure is raised to 14 atmospheres and the temperature is raised to 300 Kelvin, what is this new volume? Well, let's find out what we have first. We go P1, V1, T1, P2, V2, T2. Now we're doing the same process that we did in Gay-Lussac, Charles, and Boyle's law. All right, so our first pressure was 12 atms by setting up this little chart here. The volume was 23 liters, so all this is good so far. The temperature was 200 K. Okay, the pressure's raised to 14 atmospheres, so that goes in for P2. And the temperature's raised to 300 K. Then, of course, what is T2? So we're looking for T2. All right, so now let's see here. We're looking for T2. So we go P1 V1 T2 equals P2 V2 T1. Since we're looking for T2, we're going to go T2 equals P2 V2 T1 over P1 V1. All right, now all we have to do is put into our equation the known values. So T2 equals 14 atm. Well, let's see here. Yep. 14 atm is our P2. Correct. 14 atm times our second volume. Oh my gosh, our volume is, that's what we're looking for. Interesting. So I set this problem up wrong. Sort of. Well, we can fix it real quickly. So let me go ahead and erase this real quick. I was solving for temperature when I should have been solving for volume. You know, that's why you got to take it carefully. So let's move this to volume here. That's what threw me off. So the second temperature is 300 K and the volume is unknown. So we're going to find V2. So V2 equals P1 V1 T2 over P2 T1. Pretty cool, huh? And you can catch yourself making mistakes, and that's all right. We all make mistakes. So let's see here. So we're going to plug these values in. All right. And now we're going to put this underneath here and get 14 atm times 200 K. All right. Now we're back on track. K's cancel out, atm's cancel out. So V2 is going to equal 29.57 liters. Okay, so let's look at another problem. Let's look at one more problem. So we'll go ahead and do that. Let's clear these drawings real quickly. And we're going to look at another problem here. So a gas takes up a volume of 17 liters with a pressure of 2.3 atmosphere and a temperature of 299 K. If I raise the temperature to 350 K and lower the pressure to 1.5 atmospheres, what is the new volume? Okay, very carefully again, Remember, P1 V1 over T1 equals P2 V2 over T2. Therefore, P1 V1 T2 equals P2 V2 T1. So let's figure out what our players are. I call them the players. So we got P1 V1 T1, P2 V2 T2. So my first pressure was 2.3 atm. My first volume was 17 liters. My first temperature was 299 K. Good, I don't have to convert it, because if it was in Celsius, I would. If I raise the temperature to 350 K, there's our new second temperature, and lower the pressure to 1.5 atmospheres, there's our second pressure. What is the new volume? So now we're going to take P1 V1 T2 equals P2 V2 T1. So we're going to want to isolate for V2. V2 equals P1 V1 T2 over P2 T1. So let's plug in our known values. So let's set this up here. See, 2.3 atm times 17 liters times 350 K. And then we're going to put that over 1.5 atm times 299 K. All right. So atmospheres cancel out, K's cancel out, leaving only liters there. So my new answer is going to give me, well, the rate, well, hang on, we're going to get this number here. 13,685 divided by 448. That's after I multiply everything together. So I'm going to divide the top by the bottom. And my new volume is going to be 30.51 liters. Well, that's it for this lesson, guys. You have a snarly day, and we'll see you back here at Moose in Chemistry.